Today I will be discussing the second part of the spectroscopic technique and application chapter. In this video I will be discussing about the fluorescence and NMR, that is nuclear magnetic resonance spectroscopy. Now let us come to fluorescence. Fluorescence, as you see in the diagram, it is a emission phenomena. It is emission of radiation by a substance during its transition from the excited state to the ground state. The substance reaches the excited state by absorbing light or other electromagnetic radiations. Generally, the emitted light has longer wavelength, hence lower energy than the absorbed radiation. So first there will be absorption of radiation, and then it goes from the ground state to the excited state. And in excited state also it comes back from higher excited state to lower excited state, and finally it come back to the ground state. So fluorescent material ceases to glow nearly immediately when the radiation source stops. Fluorescence has found great importance in the medical field, especially in the detection of tumors. Fluorescence spectroscopy is also used in vivo detection of skin pathologies. As the skin contains elastin, collagen, keratin and NADH, which are chromophores, therefore it contributes to the fluorescence spectrum. Skin cancers, they can be easily diagnosed by using the fluorescence technique. Now, why it is important to study the NMR spectrum? It gives information about the number of signals, the position of signals, the intensity of signals and the splitting of signals. So these are the different types of protons depending upon the position of the signals, which you can differentiate. This coupling constant, or what is known as the J value, it is the distance between two successive peaks in a multiplet. So based on J value you can find out whether your compound is cis or trans, because cis and trans, they show different types of J value. These are the applications. NMR, it is used in structural interpretation, in metabolite analysis, and finding out the type of bonding, whether it is hydrogen bonding or not, in drugs screening and design, chemical analysis, in material science, and in medical field it plays a very significant role. For example, in MRI, which is magnetic resonance imaging, it is very non-invasive diagnostic technique which uses radio waves, and particularly used for imaging of soft tissues like brain, spinal cord, muscles, ligaments, and detection of abnormal tissues known such as tumors. As you know that protons, they are tiny particles and they are present in water throughout body. So these proton NMR spectra we can utilize to get various images, and radio waves are transmitted in pulses and they are aligned by the strong magnetic field. Radio waves are transmitted, and the echo received by these protons will help in reconstruction of images of the body by the computer. The images, they are very precise and gives you entire view of the body at any angle. So as you can see, it is a cylindrical machine where patient is put. This is very strong magnetic field, radio frequency coils, they are applied, and it will be following the same principle as the NMR. To solve few problems, let us find out the number of signals in CS3Cl. CS3Cl, it will show one signal because only one type of proton is present. CS3, CS2, CS3. If you see this CS3, it is different from this. So I am writing HA because this 3 protons, they are attached to carbon, which is attached to carbon with 2 protons. Again, these 3 protons, they are also attached to carbon with this, which is attached to carbon with 2 protons. It is also similar to this. So both, they will be HA, and in between it is attached to one side on carbon with 3 protons, on carbon with 3 protons. So it is different from these protons. So I am writing HB. So total number of signals will be 2. Now let us solve problem. A molecular formula is C7H8. It is showing singlet and singlet at delta 7.2, at delta 0.9, 5 proton, 3 protons. Now at delta 7.2 means it is aromatic proton. Aromatic means it should have C6H6. but here 5H is written. It means one hydrogen is replaced. It means that there is one substitution. Now that comes to be C6H5. C6H5, if you subtract from C7H8, you will be getting CS3. It means that substituent is methyl group CS3, which is showing signal at 0.9. So it is methyl. So the compound will be toluene. Now let us come to second, a compound which is having molecular formula C10H14. Again it is showing a peak at aromatic region, so that is 7.25. so it is C6H6, but here 5H is there. It means again one substitution. So C6H5, when you subtract from here, you will be getting C4H9. So 9H means that also singlet at 0.8 means methyl group. So methyl means there will be 3 CS3 group, and singlet means they are away from each other, so you will be connecting it with a connector. That is this. So this will be the structure of the compound.